If you have an improper fraction, you don't need to, as an answer, you don't need to write as a mixed number if you choose not to. But all fractions, mixed, improper, proper, need to be reduced. All right, homework, any questions? Jaden. All right, let's take a look at number 16.
This one was
all right, 16. Looks as the following. You got a closed circle on, what did I draw right there? Closed circle on 1, and it's shaded to the right. So step number 1, you pick a variable, x. Step number 2, you write the number, it's 1. Step number 3, the solutions are what? Bigger or smaller than 1?
bigger.
So the solutions have to be bigger than 1 except it's solid or equal to. There you go. And Landon, you got it wrong. Why is yours wrong?
I see. Well, if I had a brain. Wait, how is that?
Here's what Landon has. Why is that wrong? Because it's a solid circle, so this one would be the equal form. And it easily forgot. So I'd take off like 1 point for that. David? Let's take a look at 14. 14 is an open or closed circle, David. So it's either going to be greater than or strictly less than, either one. The number is, so I put a 2, and it's shaded to the left. That means the numbers are what, bigger or smaller than 2? So the answers are all smaller than 2. Do you see how I don't read the letter X? I find that kids do better if you kind of put it in more friendlier words. The solutions are smaller than 2. What?
Is it fun that we use highlighter because it's really hard to see?
All right, you're the one that's grading it. All right, let's grade this sucker. Here we go. I'm going to call off Kai's. You're going to answer yes or no. Kai, you didn't answer number 2.
Oh, I skipped it.
All right. Number 1, he's got a closed circle on 0, and he's shading to the right. That is wrong. It should be an open circle shade left. Number 3, he should have put open circle on 3 shade left. Yes?
Yes.
All right. Number 4, all of these are wrong. All right.
3 or 2?
All right. I will call out the right answers. Number 3, open circle on 3 shade right. You literally got all these wrong. Number 4, closed circle. Here's the first one you got right. Closed circle on -4 shade left.
That's only one kid's right.
Number 5, open circle on 0 shade right.
I forgot the open circle.
Yeah, but you're shading on the wrong side here. Number 6, closed circle on 1 shade right. Number 7, open circle on 4 shade right. Number 8, closed circle on 4 shade right. Well, luckily for you, we're going to practice this because every one we solve has to have a graph. All right, number 9. I'm just going to say X every time. So X is greater than 5. Number 10, X is less than -1. Number 11, X is greater than -2. You're getting these right. Number 12, X is less than -2. Number 13, X is greater than 2. Number 14, X is less than 2. Number 15, X is greater than 0. And number 16, X is greater than or equal to 1. You got all the ones in the back row. All right.
Got them all right.
Okay, I got one wrong. Okay?
I got them all right.
If this was the first year that I was doing with Kai, right, I would be scared. But since this is the second year, I know that Kai gets most of his homework wrong, but yet he figures it out come test and quiz day. No, this is all right. All right, so Grayson is collecting and Abby's passing out. You guys are going to write down your homework, which is another worksheet. No, you need to learn how to do it.
I know how to do it. It's the graph, right? I know how to do it. But problems. Wait, is it equations and stuff? I know how to do it. X over.
What's the
Okay,
No,
I
those
can
are the
see
fractions.
it. What's the answer? X over -2. X over
I have no idea.
20 is the answer. Negative 20 is the answer.
answer the graph?
Oh, so we solve for that and then the graph. Oh, easy. Not the homework.
You all got it wrong.
I just played one.
I just did all my homework. And I got almost all of them right other than one or two.
I don't know how to do this.
That's good.
You have to solve
But
it.
that was the easy one. Now it gets a little bit more challenging. All right.
Do we just have to draw the graph for this?
No.
So listen up, please. So yesterday was an easy one. So today is medium-ish. So we are going to solve inequalities. We're going to go back to one-step equations for 2 days. Today, adding, subtracting, tomorrow, multiply, divide. And then we'll go to two-step. We won't get anything bigger than two-step, I think. I don't think we do multiple step. Yes. Yeah,
It's easy.
I don't think we do any more than two steps, but maybe there are a few multiple steps. We'll see. Okay. So as some of you can already figure out, well, we already know how to solve a one-step equation, right? So let's explore equations for a second. If I'm given a true equality, right, 6 does equal 6, and I subtract something from both sides, does it maintain its equality?
Yeah.
Certainly so. So equality is maintained. If I start with an inequality, what happens if I subtract something from both sides? Will the inequality be maintained? Well, let's explore. 6 minus 2 is? 10 minus 2 is?
8.
So it works. But we got to be careful because the inequality could be flipped around with different numbers, right? So let's just make sure that that still works with a greater than symbol. Let's see. Let's subtract 2 from both sides. Does it still work? Yeah, it does. So for inequalities, you are allowed to subtract anything as long as it's the same thing from both sides. Because what would happen if you don't do that? True or false? That's true, right? So let's not subtract the same thing from both sides. 6 minus 2 is? 10 minus 8 is? And we clearly get an, well, this means is not less than, right? 4 is not less than 2, okay? So you are allowed to subtract the same thing from both sides for inequalities, just like you are for equations, just as long as it's the same thing. So that also works the other way around too, for greater than as well too. So if you subtract the different thing from 6 minus 5 is 1, 4 minus 2, once again, 1 is not bigger than 2, okay? However, if you subtract the same thing from both sides, you're good to go. All right, and that's what we're going to do today. We're going to be solving one-step inequalities. To insult your intelligence, let's look at one-step equalities. Where's the variable? What's attached to it? How is 3 attached to x? How do we get rid of addition? So we're going to subtract 3 from both sides, and we get, all right, guess what the difference is when we do this with inequalities? The only difference is we have to graph the solution. This is a plural, okay? So we're doing the same thing. Notice the only difference between that and that is it's got a less than symbol, okay? So we solve that inequality by subtract 3 from both sides. So we get, all right, Kai, you're on. Tell me how to graph that. Step 1. Step 2. Step 2. Tick mark. Step 3. Well, what am I going to put? Okay. What's that number?
Oh, 2.
So what am I going to write?
2.
Okay. Open or close circle. Step 4.
Okay.
Okay. Shade left or shade right, and how do you know? If you have to think about it, you don't know. So here's my suggestion. Instead of saying X, I want you to say the answers or the solutions are. Say it. Say the answers or the solutions. You can pick one of those, answers or solutions. The answers are, read, except I want you to say bigger or smaller depending upon what the sign is. The answers are, because that's the bigger than symbol. So the answers are smaller than, okay, do you understand why I wanted to say that way? My claim is that if you say that instead of x is less than 2, you'll know exactly what to shade. Say it again. The answers are, where are the numbers that are smaller than 2? That's my claim, is that if you say it that way, you can't make that mistake, or very rarely make that mistake. If you say x is less than 2, well, you got to think, well, what does that mean, less than? Well, it means numbers that are smaller. Why don't you just say smaller? Now, clearly, thank you for making that mistake, Kai. Clearly, you got to know the difference between that symbol and this symbol. If you don't know the difference, okay, then you're not going to get this right. All right, another example. Here we go. Smalley. Where's the variable, left or right side? So what's attached to it? How do we get rid of it? So one side or both sides? Okay. Can you do that math real quick in your head? Okay, it's not 5.
No, that's 12. 12 and yes, it is.
Okay, when the signs are not the same, right, you say subtract, big minus small. Then the last step is always say more negatives, more positives. Negative 12. All right, graph it for me. Tell me what to do. Step 1. Step 1.
Shade.
Step 1.
Draw the graph.
Draw the number line. Step 2. Put a tick mark. Step 3.
Write down negative 12.
Put the number down. Step 4. Open or close circle.
Open and close circle.
Which one?
And,
Which one?
close.
Why closed and not open?
Because it's equal.
Right, perfect. And now you're going to do what he said. I want you to read it from variable to number, but instead of saying variable, you're going to say the answers or the solutions are
The solutions are
bigger or smaller.
Smaller than 12.
Negative 12. Where are the numbers that are smaller than negative 12? And that's why you shade to the left. Does that make sense?
Mm-hmm.
Does that help you, right?
Yeah.
I think so. All right, one more. Fractions, decimals, don't panic. Rectin, what are we going to do to both sides? Okay, when you subtract with decimals, you must line up. If you don't line up the decimal place, if you do 3 and then put 1.7, you're going to get an answer, and it's not going to be the right answer. When you add or subtract with decimals, you must line up the decimals. But 3 doesn't have a decimal place, so you need to make 3 have a decimal place. Scratch work. What do you get? 2 point, 2 point, 2 point, 2.3. 7 from 0 can't do, so borrow 1. I know it's not. Let me talk them through the problem. All right. 7 from 10 leaves. 7 from 10 leaves. I didn't hear what you said. 9. 7 from 10. Can you be my banker, please? Right? Right? Yes? I didn't hear what you said the second time. I was making a joke. 3. Now you borrowed 1 from the 3, so it's not 1 minus 3. It's actually 1 minus 2, so it's. Now, some of you clearly, myself included, could do this in our heads. Some of you need to do the scratch work. I'll just say this. If it's a test, there's no way in heck I'm ever going to trust my brain to do it without me visually writing on a piece of paper and looking at it as a personal check step. Don't assume that you can't make a simple mistake like that. 2.3 when in fact it's 1.3. All right. Graph it. Tell me what to do. Read it. The answers are bigger than 1.3. Now, if you guys don't have any problem with greater than or less than, I'm fine with that. I just find that as humans, we're a bit more comfortable with larger, bigger, smaller than less than, greater than. Jenna, are you paying attention? Okay, didn't look like it. All right, if you know what you're doing, get started on box 1. If not, I'm going to give you a 15-second head start. We'll walk you through each one. Yeah. You still never solved the first one.
Oh.
Oh, sorry. Less, I'm sorry. Less. Graph that, please.
Wait, not gonna solve it.
If the math teacher puts a problem on the board, there's a trick involved.
Yeah.
Which is, I already know he's going to write the wrong answer. Where's the graph?
It's a negative. Yeah,
All right, let's see. First one, let's see. I'm adding 7.4 to J, so I need to subtract 7.4 from J. Ooh, subtracting 7.4 from J, that's going to be some scratch work off the side. So I got negative 3.2 minus 7.4. Hey, same signs means add. 4 plus 2 is 6. Notice I lined up the decimal place. 3 plus 7 is 10. I'm not carrying anything. And we're adding with negatives, so negative, what, 10.6? So I write J is less than or equal to negative 10.6. So my graph, number line, tick mark, close circle, 10.6, negative 10.6, and I'm going to shade to the left. Yes? Okay. Second one, I'm going to subtract 77 from, oh, look, same signs. We're going to add again. 77 and 66 is negative 83. So this one's going to say G. I'm reading it from variable to number. Notice this time I'm reading from right to left. So instead of saying variable, I say the solutions are bigger than negative 83. And that's usually all you need. You can make the graph from there. Remember, this one's an open circle. Yes? Yeah. All right. Would this work with addition instead of subtraction? Can you add something to both sides for inequalities? Well, let's see. Same drill. For equalities, can you add the same thing to both sides and maintain equality? Yeah. So if I add 2, I get another equality. So equality is maintained. Does this work for inequalities? Well, let's see. Let's do one for less than, one for greater than. Add 2 to both sides. Do we still maintain the inequality? Yeah. Well, 8 is still clearly less than 12. So inequality maintained. I should say inequality, not equality. 6 greater than 4. Let's add 2 to both sides. 8 is greater than 6. Yep, that's still this. No, I messed that one up too. Inequality is maintained. All right. Cool. I actually remember this mistake from last year, and I never changed it. All right. So let's see if we don't add the same thing to both sides, what happens. So I'm going to add 8 to one side, 2 to the next. 6 plus 8 is 14. 10 plus 2 is 12. And 14 is not smaller than 12. So inequality, we got it right that time. Do the same thing. Let's add different numbers to both sides. That's going to give me an 8. That's going to give me a 9. And 8 is not bigger than 9. So you are allowed to add and subtract the same thing from both sides of an inequality. Okay. All right. So let's see how that would look like. All right. Who's my guinea pig now? Angie, go. Where's variable? Left or right? What do we got to get rid of? That's not 7. Negative 7. How do we get rid of negative 7? Let's add 7 to both sides. Be careful. What do we get? 4. So we get t greater than or equal to 4. How do we graph that?
Number 4 to the right. Or,
Open it.
Close circle to the right.
Close circle to the right. A lot of people, after they do about, I don't know, 10 or 20 of these, all of a sudden they're like, I don't even need to think about it. I know how to shape this stuff. Just be careful. All right, one more. This is typically the one that causes problems. Why? because they see this plus and they immediately think, oh, the -3 is attached by addition, so I need to subtract, which is true. But you need to subtract a -3, which is the same as two negatives turn into, so it's add 3. The other way you think about this is how do you get rid of -3? You add 3. Okay?
I want to.
Guinea pig? David, guinea pig, go. So what are we going to do to both sides? See, that's what I'm saying. There's the issue there, right? We're not going to add -3. Technically, we're going to subtract -3 because it is attached by addition, by the way. But most people would just think, how do you get rid of -3? You add 3. Right? Whatever gets you to that 0 is what you want to do. 3 minus 3 is 0. This is the one that kicks people's butts all the time, which is why math teachers always put it on the test. Keep talking, David. Okay. What would it be? What did you get? Do that again. One more time. No. 4.1. 1 plus 3. Sometimes you saw what just happened, right? Even though he knew, not because he's had me for 2 years, right? When I say, what is it? What is it? What is it? That you know you're making a mistake. You can look at that for 40 times and not see your mistake. I don't know why the brain works that way. I know that David knows that 1 plus 3 is 4. But in his mind, he was convinced that 3.1 was the answer. Just be aware of that when you do your test corrections, like you finish your test and you're checking your work. If you go immediately back to a problem like I just did 4 times with him, you'll never catch your mistake. Because I'll say, what is it? And I'll hear 3.1, 3.1, 3.1. You take a 5-minute break, right, or check other things before you come back to that same problem. I'm going to say chances are a little bit higher that you might, oh, wait a minute, 1 plus 3 is 4. All right, David Graff. Tell me what to do. Open or close circle. And I go to the right. Okay? I would love to, like, write a big, long technical paper on why people make math mistakes type thing. Or how do they catch math mistakes? Because it's an interesting thing of, myself included, where, you're just looking at something, you're like, yes, it's right, it's not right. All right, once again, I'll give you guys a 15-second head start, and then I will walk you through this one. Did you ever get this answer?
Yeah.
Well, this says x is smaller than -20. This says x is bigger than -20.
I mean, small.
Yeah, you're both wrong.
Oh, well,
There must be a trick or something.
no. I guess it has to do with the graph. Like, I thought you used 10 as graph.
Remember I said the inequalities are pretty close to equalities, but there is a difference.
Yeah. Like,
Tomorrow we will explore that difference.
oh, so we're wrong.
Yeah, that's wrong.
Can I have the worksheet?
No. All right, here we go. First one, let's see. I got to get rid of -15. So I add 15 to both sides. 3 and 15 is 18. So I get n is less than or equal to 18. That's going to be closed circle, shade left. Obviously, the number's 18. Do you understand why I don't have you write more than a bunch of numbers?
Mm-hmm.
It just seems like it's extra work. Okay, what's the next number?
19.
What's the number right in front of it? It accomplishes nothing other than waste your time and my time.
18.1.
Right, and if we're going to go by
17.9,
tenths,
17.9.
right, if we went by tenths, that would be true. Okay. Second one, let's see. I'm going to add 6 to both sides. We better look at this one. Add 6 to both sides. That same or different signs? Different sign means subtract. Big minus small. 6 minus 4 is 2. More positives, more negatives.
-2.
More positives. So is n is greater than 2. You will make these mistakes forever if you don't slow down and think about Same or different signs. Add or subtract. Big minus small. All right. More positives, more negatives. So let's see. That's open circle, shade right. Yes? All right. Open circle, shade right. Everyone spun the.
What?
Everyone spun the
Add, subtract, the solve inequality.
fractions. Okay. All right, so let's do some with fractions. Oh, by the way, here's an algebra 1 fraction next year. You ready? Jane, you want to try it?
Sort of. Let me
No.
try it. Wait.
Like, I kind of want to. Okay. I don't want to get it
All right. This is next year, so not this year.
Wait. No, go back.
This was a student 3 years ago. They wrote this on the paper, and I said, that's classic. I got to take a picture of that.
All right. This is easy.
Question mark.
No, it's 1 plus the fraction 1 over 1 plus the fraction 1 over 2 plus the fraction 1/3.
Maybe that's hard.
All right. Ours are slightly easier. Not next year. All right. We got a mixed number. We got a proper fraction. What is always my advice? I'm telling you, and I got to pound this into some of your heads. You do not know how to subtract with mixed numbers, right? Everyone knows how to subtract with improper fractions, right? When it works out perfectly, and it's 3/4 minus 1/4, you're good to go. But as soon as we have some weird thing like 1 1/2 minus 6 7/8, the wheels fall off. There's nothing to borrow from. This is too many negatives, right? If instead I write this as an improper fraction, then get common denominators, it's easy. For those of you that refuse to listen to me, you're going to continue to get these wrong. When you're subtracting something larger from something smaller, you know, it used to be reversed. It used to be 4th, 5th, 6th, 7th grade. It was 6 7/8 minus 1 1/2. So that when you borrowed, there was something to borrow from the 6. You're only subtracting 1 and a little bit from 6. There's lots to borrow from. There's not enough to borrow from over here, right? You can borrow 1 and then you're out of things to borrow from. So listen to my advice of always write things when they're mixed numbers as improper fractions. 1 2/3 as an improper fraction is what? 5/3. So convert mixed numbers to improper fractions. Listen to the math teacher. Because, oh, by the way, guess what we're doing to both sides? Right. If you did not, it would be 1/3 minus 1 2/3. What are you going to do? There's nothing to borrow from. You can't subtract 1 from 0. There's nothing to borrow from. However, when you write it like that, we subtract, oh, this gets messy, right? When you write it like that, see how much space that takes up, right? So maybe we need a space for scratch work, right? So I need to do 1/3 minus 5/3. That's easy. What's 1 minus 5? The common denominators. 1 minus 5.
-4.
See, I'm saying no one will make that mistake if you change it to improper fractions. 1 minus 5 is -4, so we get -4/3. I'll take that, replace that mess right there with -4/3, and that's the answer, because it's a one-step equation. Inequality. Open, close circle, shade.
To the right.
Okay, so close circle, shade to the right. Okay? And by the way, since I only make you write the number, you don't have to write any of the numbers. This is probably the one where I would say most math teachers would call me being very lazy with my students. Because most math teachers would want you to place this between two whole numbers. Well, let's see if we can do this. -4/3 is between, I shouldn't say whole numbers, integers. -4/3 is between what two integers?
-1 and
So -1 is over here, because -1 is really -3/3, and -2 is what, -6/3?
Yeah.
Right? So it'll be somewhere over here. Now, if I could be more precise with better tick marks, but if you're ever asked to put whole numbers, that's what they want, or integers. Yeah.
Can I give you the answer to the question? I couldn't do it in my head, so I jumped on the calculator real quick, and it
Because your calculator is giving you the mixed number.
Oh, so it's 3 1/3?
Yes.
I got that right. See?
Well, it's 1 1/3. It's not 3 1/3. It's negative 1 1/3. Well, you typed into something really weird.
I did.
What?
So this can be fractions.
Sure can.
Button.
There's a fraction button on all the calculators. You just need to know what buttons to press.
Look, I got it
Right.
right.
I figured it out.
For this question, I got it.
All right, here we go. One more. Let's see. F's on the right side this time. I got rid of a positive 3/4, so I'd subtract 3/4. This one really does require scratch work. Okay, so scratch work. I got to write 7 minus 3/4. So I'm going to write 7 as 7/1. Common denominator is
4.
so 4 times 7, 4 times 1 gives me 28 over. Okay. Anybody lost the one I just did right there? Jenna, what did I just do? What did I just do mathematically? What? What did I do mathematically? How did I turn 7/1 into 28/4? What did I do? I multiplied top and bottom by 4. Okay. Now it's easy. 28 minus 3 is 25. See how much easier that was? Right? No, I'm not going to write it as a mixed number. I'm just going to throw that as the answer. Be careful. Remember, I put equal signs right here. Just remember, you're not dealing with equal signs. You're dealing with inequalities. Okay? This is equal sign absolutely over here. But when you transfer it back over, occasionally kids will forget and they'll put an equal sign. All right, so let's see. Open and close circle. Closed. All right. Shade to the. Read it. The solutions are smaller than or equal to. Now, if I were to ask you to give me 2 whole numbers, now you got to think about this. So what's the 2 whole numbers to the right and to the left? That was pretty quick, and he got it right perfectly right off the bat. Because 25/4 is actually, oh, that isn't right, is it? It's not 5 and 4. It's actually 5 and 6. Okay, because this is actually what 6 and 1/4. So it's actually not even that. It's actually 6 and 7. Be careful with that. I don't ever ask that question, by the way. Maybe I should. Maybe that'll be a bonus question or something like that. What 2 integers is that fraction between? Okay. All right. You got 4 of them, and I believe that's, oh, we got 1 word problem. All right.
3 1/3.
I actually haven't done the problem in a long time, so I don't know what it is. Did you write it down correctly?
Yeah, it's X divided by A is greater than.
If I get this right, no
For a week.
For a week.
And if I do not get it right, then I have to do 3 worksheets.
Yeah, it's a bit.
I should have put the bad in for the quiz.
No, no. Bet that if you get I probably get right.
You got it way wrong.
Yeah.
27 over 10.
Print out the worksheets.
Wait, no, what's the
2 and
trick with the-
2 and 7.
I'll take some of these.
What now? I'll teach you tomorrow. It's tomorrow's class.
What is it? 27. What do you mean? I was actually kind of right.
You weren't far off, but I have no idea what you got your number.
Yeah.
All right, here we go. First one. X is less than 3 if you subtract 9 from both sides. So open circle, shade left. Bottom one, let's see if we add 1/3 to 5. That's what, 15/3, and 1 is 16/3. Right? Right. So close circle, shade right.
Yeah.
Right. I'm very lazy. I didn't have enough space, so I wrote my fraction really weird. Subtract 3 from both sides, we get -4. So open circle, shade left, -4. And the last one, let's see, we got to add 2/3. Let's see, 2/3 to 4 2/3, 4 2/3. I'm not going to do it I'm going to always change mine to improper fraction. So at 12, let's see, that's what, 14/3 plus 2/3 is 16/3. So it's positive 16/3. Open circle, shade left. 16/3. Okay.
Good.
If you wrote what, that's 5 1/3, that's fine as well. Questions? Oh no, we got word problems. All right. So they're going to ask you, just like they asked you to write equalities, they're also going to ask you to write an inequality. Inequalities are more challenging because sometimes it won't even have the word for the inequality that you need to use. Like it's not going to say less than. It's just going to have a real world problem that you're going to have to somehow try to divine the information from the given words. So read along silently as I read along out loud. A hard drive on your computer has capacity of 120 gigabytes. This is a pretty long time ago when they wrote this book. You've used 85 gigs. You want to save some for some videos. What are the possible sizes, plural, for the home video collection that you can save? Notice it never says less than or greater than. So it says, write an inequality that calculates the potential size in gigabytes available for your video collection. How much space is your hard drive? 128 or 120, right? You need to be what? Bigger or smaller than that? Right, because you got to fit it on that. That's as large as it can be. But I also have to subtract what we've already used up. How much have we already used up?
85.
So if X represented how much we can put on, right?
120.
Now be careful with subtraction, right? It would be X plus 85, and that number must be bigger or smaller than 120.
Smaller.
Or the same. So there's your inequality.
Couldn't you just put 85 on the other side and say minus?
We could, yeah. Because think about it, what's the first step you're going to do?
Subtract.
So yes. So what's 120 minus 85?
35.
How much?
35.
Okay, so we would get, let me catch up with you. We would get that. Except there's one little sneaky little thing going on here. When you deal with inequalities, when does this ever stop? Except this is in the real world. So can your computer ever have negative gigabytes?
Yes.
So how?
Yeah.
Right? On my PlayStation, that's 500 gig hard drive, right? So as soon as I put too many games on it, it says I have 0 space left, right? It never says I have negative 400 gigs, right? So when you graph this, guess what? We can't use arrows. So what does this real solution say?
Line segment.
I got to use a line segment. So where's my line segment going to go from?
35 to 0.
I would say it the other way around, but yes. Normally, right? Normally we would write, number line, tick mark, closed circle, shade to the left. But our problem is we can't go past 0.
Or 120.
Yeah, but we're not anywhere near 120. We're going to 35, right? So my number line, even though it will be a number line, will be 2 tick marks. The one on the right is going to be what number?
120.
Oh no,
35.
35, and the one on the left is going to be, and that's what it's going to look like.
Couldn't you put 120 on that side, put a tick mark?
Yeah, but it doesn't say anything about how large. It says how much do you have available for use to put your videos on. I don't have 120. I got anywhere between 0 and 35 gigabytes. That make sense? All right. We got 5 minutes left, or do we? Yeah, we got 5 minutes left. So get out your homework and start on it, which is a worksheet.
Wait. You don't have enough.
No, that's my heart still burns with anger and hatred of those people. And
I'll take that as a no.
I spent hours that night. And my hopes and wishes of a good Christmas were crushed. And I will be sitting in a dark, deep stew of anger and resentment this entire holiday season. And I didn't get a PlayStation. No, because I want to play it on the PlayStation 5. So my only hope is that by some miracle someone makes enough of them.
Because they want to get the new game, they want to play on the console. You can get one for free.
There's videos on YouTube of people that buy like 10 broken
Mr.
ones
Charrier.
and they make a good one out of 10 broken ones.
There are Taco Bell. He got this shit when it came out.
Mhm.
Two Taco Bell.
Well, Burger King is offering PlayStation 5.
Yeah, if you get like the 2 for 5 thing.
I'm gonna get into the fatter.
I tried getting it last night.
The way you
Or I could go on eBay and spend $5,000 on one.
There's that much.
Well, look.
She's never had Taco Bell. Never had Taco Bell. Sad. You turn my phone.
Taco Bueno.
That place was the bro problem.
You're gonna find out there's something else. But remember, it was negative. So negative 2 times 10 is negative 20.
Yeah, wait, was that correct though?
No, but we'll talk about it tomorrow. There's a difference when you do multiplication division. But it's a good guess. All right, e-learners, any question? No one's online, so obviously you have no questions. But if you are viewing this later and you have questions, email to me or chat with me. I will catch you tomorrow.